All right. Somehow I see we have managed to lose about half the audience we just had, which basically means we now have a really comfortable amount of space in this room. I think somebody could lie down if they want to. I am just going to wait for a couple of seconds for the guys outside to wrap everybody up and get them inside here. All right. Let's see who turns up. Alright, you know what, I'm just going to continue because if people come in, then, well, they just have to catch up. Again, welcome, nice that you're here. Actually, in the other room, we have gone so far as the introduction, so basically I'm just going to continue from there because actually I haven't told that much yet. Web applications. Actually, a couple of years ago, not even that long in human standards, but ages in computer standard, there were things called web pages. They were individual HTML pages, not doing that much, just giving information. Interaction was really limited, maybe to just a couple of small forums for like leave contact information, stuff like that. Since then, web applications have occurred and they have evolved. Actually, nowadays a web application is basically more or less an API instead of a page rendering device. Pages get loaded by loading a HTML skeleton. All the individual items on a page get loaded through JavaScript, through asynchronous calls. So basically, it's a lot harder for a CMS or an application to keep track of everything. Also, web applications are just the top layer. They're just the outside looking part of an entire infrastructure. And this infrastructure consists, of course, of an operating system, which usually, in my case, is openSUSE, and which I'm sure you share with me. Database servers, usually in web environments, that's going to be MySQL or MariaDB, like nowadays. And a web server, which has a pretty good chance of being Apache. Actually, all these components interconnect with each other, and all these components offer interfaces towards each other, going back and forth, which all have very nice intersection points, which a possible attacker could tap into to get information. Not again. For some reason, my laptop is suffering from Monday morningism, I think. So I'm going to do a reboot again and see how far we come this time. Actually, I've experienced that recent KDE versions do not handle display switches that well, at least not in case of my laptop. So basically that might just be the case. Well, as I've demonstrated, I run openSUSE. All right. Think you guys might too. Maybe. Got a pretty good indication for being here, actually. So, yeah. Yeah, it's actually annoying. It's only the X session that freezes and the rest just keeps going on, but for some reason it's completely unable to recover itself. It's well, I consider this to be just a nice pause on road to a lot of information, so you can digest it and I can speak about it in a little bit slower and more controlled fashion. Right, we're here again. Well, should be good. All right, that looks familiar. I think by now this also looks familiar to you. Here we go. Multiple interconnected components, which basically mean more connections or more complexity and more doors to knock on. Every interfacing point in your application could be a potential attack vector. Is that something to be scared of? Well, no. I mean, I get a lot of colleagues in the security field who will daunt customers with 1,000 possible attack vectors in their application and how they should be scared to death that somebody will steal information and such. Well, I don't think it's that much to be scared about. I think you should be aware of it. So I think you should, at every level in the architecture of your application, take measures to prevent, at least to the best possible extent, the fact that somebody could get around the means that you try to put in place. I will talk about some of the possible hardening stuff like Modsecurity, AppArmor later in this talk, so bear with me. Actually, what I usually preach is doing a risk-based approach. Risk-based, that is, from the customer risk aspect. Because you can simply secure everything if you want to. If you want to, you can run every server with SA Linux, and basically this would become an entirely unmanageable mess. So, first of all, what I do is try to determine what would be the actual worst thing to happen to any part of the infrastructure and the effect that would have on the web application. Well, if you look at infrastructure, mostly the web server or operating system, that would mean the application wouldn't work. Well, is that necessarily a bad thing? Yeah, sure, it's not desirable, but if it goes down, actually, there's not much that can go wrong with it. It's not like an application which goes down can be hacked at that time, it's just not working. This could also be a countermeasure. We'll get into that. Same with the database server. If that goes down, well, you usually get some kind of error. Of course, you should limit the amount of information you give in the error, but basically this would not mean that much. Actually, what could be more intrusive is actually the web application being hacked itself, because that could actually potentially change the communication you have from the website to the customer. Let's take an extreme example. If you're a government agency working with refugees and you have a website, you basically would not want some like extreme right organization hack into that website and put something like a swastika on it. That might be considered bad. So, and this also works for e-shops or something like that. I mean, if you have this web shop and it get hacked, not necessarily that is only to do about customer information, but this could also be simply some disgruntled ex-customer trying to damage your business by putting up like porn or something, which at least for web shops might be considered bad. Second, identify the possibilities why your application could be a target. Are you using personal identifiable information? Are you storing like bank information? Are you handling money? Basically, the level of personally identifiable information pretty much determines which level of security you should enforce on your application. And actually, there are pretty much obligated by law. Actually, in the European Union, it will become legislation very soon that if you handle personal information and anything gets leaked, you be obligated by law to actually inform your customers about that. So it's going to be one big, very nice public naming and shaming game. Keywords here are availability, confidentiality, and integrity. Availability, simply because if you're a web shop, your website should be reachable. Confidentiality, well, if you're preparing a very nice customer campaign, you basically don't want it to leak out before it's started. Or if you, for instance, sell reduction coupons, you don't want them to end up on Facebook before the actual campaign starts. And integrity, if your complete order database is mangled, you also have fiscal problems because you cannot reproduce the actual transactions that you did. Well, why is this a problem then? Because usually when I talk to clients and I explain them the first, like, okay, let's take a risk-based approach, then usually a client is able to actually identify this risk and mostly see the reasoning. But actually, it becomes interesting if you translate it into direct consequences for this client. So, like loss of revenue. Your web store is offline, which basically means people will not be able to do transactions with you, which in turn might cause the loss of potential customers. But also bad publicity. Actually, that last part might be even the worst part, because the internet never forgets. And anybody who will Google your website will find this bad information years and years and years later. That is actually really bad. But also, incorrect information could lead to serious problems in your logistics processes. Not only logistics, but even worse, if a web application contains like pharmaceutical information regarding medicine usage and stuff like that, which in the Netherlands actually is quite a hot topic because everybody seems to be evaluating online patient dossiers. I really am a bit scared that if an application, and this goes much to the integrity part, gets hacked or gets malfunctioning and referential integrity might be lost, you might end up with wrong medication, which potentially can cause problems. And this is actually a pretty new way of using web applications. I mean, like 5 or 6 years ago, even that's short, web applications were almost not considered for that type of sensitive information. But nowadays, when you look at hospitals, they're mostly connected to universities, have large-scale IT networks, and web applications seem to be the way to go. But also, this mostly are publicly available systems. So, actually, I usually am not scared about web applications going down or simply stop working in any way at all. The thing I would be scared about most is integrity issues. And misinformation could also overload processes. To give you an example, we had in the Netherlands recently an issue with something called a Project X party, which was in this little town in Haren, which is in Groningen, which is completely unpronounceable, but alright. Actually, a girl of 15 years old, of course, usually turns into 16, throws a party, announces it on Facebook, forgets that she should have crossed the private option there, and more than 10,000 people showed up in a village which has only just about 4,000 people living there, which have like 2.5 cop or something. So that was completely out of control. That is also a problem in web application or applications in general, it's not only the fact that you could be targeted by a hacker, it's also the fact that your user can do stuff that you don't predict, or the stuff that your user does has consequences completely outside of the scope which they can imagine. So that's basically, is that a hack? Is that an attack? Well, not in the traditional sense of the word, but if you look at the consequences, actually this little village of Hardening had millions and millions of damage. Well, I pretty much consider that a problem. All right, what is a hack and or attack and or incident and or anything you want it to call it? Actually, it's just about anything which is aimed to disrupt the normal functioning of a process or application for that matter. Overloading with misinformation, overloading with false requests, DDoS attacks for instance, and trying to find entrances into a system which usually are supposed to be behind some kind of authorization mechanism. Actually, that doesn't differ that much from traditional physical security. I mean, you have server rooms which have big locks, which have key cards, which have fingerprinting and stuff like that. Basically, it's the same, but the only problem is with the web that it gets out really fast. News gets out really fast, and simply, it's out of your control. All right, top 10 attack vectors. Everybody know OWASP? I see one hand, rest is asleep, or, all right, cool. Welcome back. OWASP is a foundation which basically is formed to get people aware of internet security or electronic security, and they keep this very nice list. They have a top 10 of attack vectors: injection, cross-site scripting, broken authentication and session management, insecure direct object references. The rest you can read up there, and my voice is already bad, so I'm going to leave it at that. But I'm going to go into each of them to explore them a bit more. All right. Like I said, this presentation basically is a brain dump of a process that I usually follow to test applications. So I'm sorry, but sometimes the sheets are going to be really filled with text, but I'm going to go through them and you can look at them later. They'll be put online, at least I hope. Injection. What is that? OWASP always has a definition part, which I simply copied because they're really informative. Basically, it states that injection occurs when untrusted data is sent to an interpreter as part of a command or query. The attacker's hostile data can trick the interpreter into executing unintended commands or accessing unauthorized data. I think most of you have seen examples of SQL injections, like adding comparators to queries. It's actually amazing because SQL injection has been as old as there have been databases that this is still a problem. But actually a lot of custom built applications are still pretty much vulnerable to this. Basically, you should test an application if it does this by simply using a login form, for instance, and adding some SQL to it. Just see what it does. You'd be amazed. What to do against it? Well, actually there is this basic paradigm in IT security is simply don't trust any data that comes from a source outside of the actual code of your application. Simple. Even if information comes from the file system in files that you may have stored, session files or something, these can be altered, these can be doctored, these can be filled with malinformation, or at least they reside outside of the scope of control of your application, and that is something to be aware of. You can also simply interpret this as follows. You should validate anything that goes in and filter anything that goes out. Because actually filtering of information going out of your application I'm going to go into that a bit more in other attack vectors like cross-site scripting and stuff like that, is just as important. But basically, injection is pretty easy to mitigate. Actually, one of the basic fantastic features about PHP is that it's type unsafe, or unsafe, at least it's flexible about it. That's great because you don't have to cast your variables every time, you don't have to exactly know what a variable is going to be. Cool. But since just about any other system or component in your application will not be type unsafe, actually, when communicating to that, you have to do a lot of stuff yourself. Old-style MySQL drivers for PHP had the fantastic feature they would do a lot of typecasting. Yes, fantastic. So now I really don't know what's going on anymore. Basically, what you should do anytime you interact with a database is simply casting information to the type you want to use it, which can be very easy because usually CMSs, for instance, have integer-based IDs of pages. Well, if you already know that something is going to be an integer, simply cast it to int. Do that, because you would not need any other information. The worst part that can happen if you cast something to int, you get a 0 or you get a 1 or something, but still it would not possibly be injection. It would simply be something else, which I'm going to go into, broken authentications. Also, check the size of your input. Normally, a database field would simply have, in case of a varchar, have a length of 255 characters. Well, simply limit your input to that. And also raise an error if it exceeds that input, because you also want to educate your user for doing something with the application that it's not designed for. Basically, you can also do this very simple by doing a describe table query before you handle form data. Look at some of the constraints, like length, and simply do that dynamically. You don't have to alter every form for that. And use whitelist validation instead of filtering out stuff. One of the basic problems with PHP is the strip tags function. Because it actually doesn't strip tags, like looks for valid HTML tags and strips it out. No, it looks for a pattern which consists of an opening and a closing character, and has no sense of tags at all. So you should test it actually, like put these kind of operator or characters in a string, put it through strip tags and see what it does. It's horrible. Actually, it's that bad that if you rely on that to like filter user data, you end up almost certainly with malformed HTML, which screws up the rest of your application. Use something like HTML purifier or something. It's a whitelisting based approach. You can simply specify which tags a user may or may not use, and if you audit this, you should look for usage of that. Actually, I usually do a simple search through the source code of an application if strip tags is used. If strip tags is used, that is a red light for me to dive into the application more, because actually this usually means that a person is at least aware of some of the concepts of input validation, but probably doesn't know very much what he's doing, or she is doing for that matter. That might also be the case. Also, you could actually consider adding honeypots. If you are a website owner and you are experiencing high traffic due to attacks, then it's pretty easy to filter out patterns. If you see that your application is being tried from certain URLs, actually you can simply store those requests, maybe by even hashing them or something, the string. And if you actually have that information, it could be interesting, because then you can test for that information and lead this possible attacker to something entirely else. like a static HTML page or something, which basically looks like your site, but doesn't do anything at all. Much fun with that. How to audit injection prevention, actually. What I do is I do a search for the usage of the raw get, post, and request variables. As you may have noticed, this audit is basically done for PHP applications, but this methodology works for just about any language. All of them have methods of accessing raw, post, or get data. Check that, look for that, and see if it's done. If forms are actually validated and not only like tested for empty or is set or other intelligent stuff like that. Check if a recent database driver is used, like PDO or the old style MySQL database driver, because PDO actually out of the box doesn't allow more than one query per action. So if an attacker tries to inject SQL commands into an application, PDO by default will simply ignore it. Mostly. Do not take this for granted, by the way, but still. Check how queries are constructed. Check if it works with placeholders, if it works with prepared statements, stuff like that. That is usually a pretty good indication if the application was designed by a person actually aware of best practices in a language, and also if simply basic sanity is applied on input validation. Check if the magic quotes are off, because if they're on, I simply would suggest you do a shift, delete, and run away. That also goes for a thing called save mode. Anybody ever encountered that? Trust me, if you see that switched on, run. Also, and simply test what happens. Simply put a delete from users or something. If you do black box testing, you would not have any knowledge about the database model behind it, but you'd be probably not surprised that a lot of applications have a table called user or users or profiles or something like that. Well, simply do a delete from that table and see what happens. And also test if form data is stored in a database unfiltered or unencoded. It's not evil to store HTML in a database or something. It is, however, if you do it unvalidated or uncoded or anything at all. I've seen some bit paranoid, but okay, go so far as to base 64 encode everything before putting it in a database to at least prevent that type of attack. I don't actually think that's much sense, but still it could. Alright, number 2, cross-site scripting. That actually is fun, because actually a lot of applications are also vulnerable to that, and it offers you the possibility of actually injecting stuff in the website to make it look differently. In the Netherlands, we had this really nice incident with a right-wing politician, a bit extremish right-wing, who had his website probably built by his nephew in his garage or something, I don't know, because actually the title of the page would be embedded in the get, in the URL. So if you would call that site and that page with another title in the URL, you would actually get pretty funny results, because since this guy's only issue politically is like he hates Islam and should think everybody should go away, there was this whole campaign of Google bombing him with a title, I love Islam, which basically was a bit embarrassing for this guy, who actually is an embarrassment anyway, so let's not go into that. Actually, cross-site scripting can be remedied in just about the same way you do injection, because basically cross-site scripting is just another type of injection, but actually it's the result of injection. So simply do not trust any input by default, even if it has previously been stored in a database or even in a simple file or something. You should check everything. Also, do not allow for external input, external references to be used. A nice example of that is image files like avatars. A lot of applications previously, like PHP BB, had the option that you could provide an URL to an image, and then when you would be displayed in a PHP BB page, it would actually access this URL to input your image into that page, which basically was fantastic because PHP BB would have this authentication mechanism, which was not very well, but still. Actually, you know that you can dynamically generate images through PHP, right? This is cool, because actually what you could do was simply offer a link to a PHP file, which, while serving an image at the same time, hijack the user session of the PHP BB user. Well, voila. That is not exactly cross-site scripting in the usual sense, but it can be. Like I said, information like session cookies or something like that, they can simply be used to take over a user session. Also, be careful, because actually, if you download an externally referenced file, this could create really nice possibilities, because HTTP protocol supports redirection. The fact that the initial URL you get from your user seems entirely legitimate does not mean that the curl command afterwards will end up at the same page, because if there is a redirect after that, you end up at somewhere completely different. This is also bad. So use curl anyway and disable redirects. If you want to import anything from externally referenced sources, you should simply only accept something that is actually there at the time you want to download it, and else simply bail out. Encode input, just like that. Be careful with strip tags, like I said before. Actually, really look into HTML Purifier anyway. So basically, who of you already knows HTML Purifier? Is anybody using it? Cool. Well, I hope you will look into it, because it's really nice. You can do a lot of whitelisted filtering with that. And also look for the usage of server, the super global. Actually, the server super global contains unfiltered data from your web server, which basically to your application is an external source. So, just like I said before, filter that. How to audit this? Well, basically it's similar to SQL injection or any kind of other injection. And also look for the usage of server variables, because they can also be overridden. The PHP self, for instance, is a variable that is pretty easily alterable if you supply Apache with the right information in a get statement. Look for that online, it's cool. Number 3, broken authentication and session management. What is it? Well, functions related to authentication and session management are often not implemented correctly. What do I mean with that? A lot of applications basically only guard the front door. They only protect login forms. They only protect information directly reachable through the application, but not very much use any protection on third-party items like files or images or something like that. Broken authentication and session management also means that you should have at least a basic understanding of how to use like redirect variables or redirect URLs and stuff like that to actually test for the source your user came from. It's not perfect, but security basically is not making every aspect of your application perfect. Security is actually building up a layer cake of so many steps that a potential attacker should walk through before reaching your application, that somewhere in the meantime he goes frustrated and leave, or he goes back to his client and says, well, fuck that, I've done 16 hours of testing and I still not in this application. This is going to cost you money. This is actually what you basically want. I hear a beep, but that's not me, for instance. Finally, my laptop is still running. Also, if you audit for sorry, if you audit an application, look for 2 simple validations, like session logged in. You'd be amazed how many applications simply do an authentication and then set a session variable. Hey, I'm logged in now, so trust anything I do. Yeah, cool. Because this also can be forced pretty easily, and also if you run session or multi-applications from the same web root, this can override each other and stuff like that. It's really nasty. What you should do is check if an application not directly checks something in the session, like if session logged in, show confidential information, but if it uses some kind of standardized method to do that, which actually also looks to some context. You can make a function in an application or look for a function is logged in, which checks also for a session variable, but which also may check for stuff like refer URL or previous encounters with the site. Basically, checking if a session exists should not be in your application logic flow, but should be a specific standardized components handling that, and you can check for that. Basically, don't use integers as user or profile IDs, because you can do a lot of nice traversing stuff with that. And also, mostly user ID 1 represents the global administrator. So if you have some kind of session hijacking which can elevate to user 1, specifically like in Drupal, the user 1 is God in the application. It can do everything. You should use something hashed or UUID as a user ID, because it's a lot less predictable. And to audit that, test for that. How to test or how to audit? Well, actually it's pretty tricky, but also check what I call here the background or the back office. Namely, if your session data is stored securely. PHP sessions are basically stored in flat files in your file system without that much of checks and validations about their input. So actually, if a hacker gets to the temp folder of your server, which mostly is like public readable or writable anyway, it's not that hard to retrieve a session and alter information in that session. Also make sure session cookies are HTTP only, which prevents the possibility of JavaScript interacting with the session cookie. Of course, this is a client-side measure, so it's not perfect, but again, security is not by making each item perfect. Security is by raising the bar high enough to simply make somebody demotivated. And check, which is really fun to do, check with a debugger what is actually in the session. You'd be amazed. A lot of applications simply swamp the session. They just keep adding and adding and adding information. And this is not only a problem because it's really inefficient. I mean, the PHP interpreter must parse all this information on each request, which get pretty ugly. It's also a perfect source of information about clients, for instance. If you run an e-commerce solution like let's say something old like OS Commerce, look into the session. Actually, there's personal information stored in there. There's references to addresses, to bank information. It's mind-blowing how much information is actually in that session. So the best part about that being an attacker could be that, hey, I do not need to hack the actual application. I simply get all the session data and I'll parse my way through that. Which effectively is a nice bridge to this subject, insecure direct object access. Actually, what is it? It's the possibility of an outside party to access something in your application that is usually only available through authentication by authenticated measures and stuff like that. These could be uploaded files from a user, images, stuff like that. What to do against it? Well, you have the htaccess files, of course, which you should simply not use that much because they're a performance penalty, which can actually cause problems by themselves. But still, if you're on shared hosting, it's mostly the only thing you have. But your basic paradigm should be to test and also design your applications to not store anything remotely private in the actual web root. Because by design, the Apache web root or any web server web root, for instance, is public. Should be public, actually, because else it wouldn't be in the web root. A lot of modern web applications like Drupal or WordPress or Magento or you name it, they actually have configuration options to store private files outside of the web root. Do that. And you can audit for that as well. Also, you can use things like openBaseDir. How many of you have heard of openBaseDir in PHP? Again, new topic. openBaseDir effectively limits in the PHP configuration the scope of where the PHP interpreter during runtime can look for files. So you can simply restrict it to the web root and to some private files folder. Any application should always run with the minimum set of permissions needed. You can also use AppArmor for that. AppArmor is actually pretty nice. It's also whitelisted, stuff like that. I'll go into that later. But yeah, simply how to audit. Check actually if anything private is being stored in the web root at all. And if so, make sure it gets out of there. Oh yeah, symlinks usually are also a bad idea. Because if you encounter symlinks in a web root, effectively that means that some other part of your system is also reachable. And the beauty about that is that this other part of the system might be a part that your client might not perceive as potentially public because it's outside of the web root. So check for symbolic links and stuff like that. Cross-site request forgery. Yeah, it's basically also something that actually is pretty close to cross-site scripting, but then done, let's say, from a different application towards your website. So instead of inside out, it's coming outside in. What this basically means is that somebody is trying to pretend to access your application as would your application normally do itself. Why is this a bad thing? Well, actually, usually, if an application receives a request, then it gives a response. And in this response, there could be a lot of interesting information like session data, session IDs. And this also allows an attacker to force requests towards an application which the application perceives as being legitimate by the user. But in fact, it's not by the user, it's by some remotely controlled script which is trying to access the server. What to do against it? Well, again, never use anything else than HTTP-only session cookies at all. And see the previous points regarding cross-site scripting and injection. Look also for in forms, if the form actually has some kind of request response validation, like a salt or a hash code being added as a hidden element to a form. Because this salt or this hash code you can generate when generating the form. You can store this in a session. You can test when the form information comes in from the user, when the post request is done, if the correct salt is there. And if it's not there, then the request did not come from your application. So you can simply ignore it. Look into that. It's pretty easily doable, especially what I also check when I audit an application is if the application uses standardized form generators, like Zen Framework form generator, which actually is pretty horrible, but still, it does add hashing to forms. Check at the very least if forms are being made by a generic component which does form generation and input validation, or if forms are being made dynamically, or also nowadays if forms are being generated client-side. Because a lot of JavaScript libraries nowadays are pretty well capable of simply rendering forms themselves, so there's not much server-side interaction going on until you receive a request. You should at least also then try and embed some kind of hashing and validation, or at the very least check for the referrer URL where an actual input came from, or at least just as long as that's safe. Actually, it goes back to the first part, injection. Know where your data is coming from, filter it, validate it. Simply do not trust data from outside by default. Another attack vector, security misconfiguration, which is pretty close actually also to the aspect of unauthenticated object access. I'm gonna take a sip of water because my throat is starting to feel like a desert. Security misconfiguration, actually most software you will install with openSUSE or with some other obscure Linux distribution like Fedora or something. Out of the box, on installation, it's not being configured to be used in a production environment. Actually, it's mostly configured to be used in a development environment, which basically means that it gives back a lot of information about the installment, about the actual errors, about error codes, about at least a lot more information which to the regular user is not relevant at all. But it's yeah, it's simply on by default. Basically, security misconfiguration can be mitigated by simply check the configuration of all your items, like in the PHP ini file, check if expose PHP is off, if display errors is off, stuff like that. If you have errors in your PHP code, it should not be visible to the user. It should go to some kind of log file. Basically, this is a lot easier actually to look at it, because if it's in a log file, you can look it up, and if only the user sees it, you will not know the error. And also, stack up a line of defense. Here we go again with the layer cake. On a basic OS level, use a firewall. Simply open only the ports that you actually are willing to expose to the world. If you're on shared hosting, this is usually being done, but even then check it. But if you do check this on a hosted environment, you should inform the hosting provider about that, because he usually will not be very happy if somebody does a port scan unannounced. This could basically destroy your contract. Use a web application firewall like Modsecurity. I will go into that later. But at the very least, and openSUSE does a good job on this, use specific user accounts for running services which do not need global access. Like if you run a web server, or if you use a database server, then simply have a separate user for that, which only is allowed to touch and alter what it's supposed to do. AppArmor can help you with this also, but basically it's good practice. And this also is important inside the application. You would not know how many times I see web applications which run with the MySQL root user. And somebody would be like on shared hosting, and every application would use the same login information for the database. Why? Do these applications even need to have access to each other's data? Well, usually not. And the only thing you actually are doing is enforcing, or at least opening up possible trouble. Database update scripts. If you run like multiple instances of a content management system like Drupal on the same web server, and you all run them with the same MySQL user and everything, yeah, well, that's a disaster waiting to happen, because if one of them goes updating, your schema, database schema might change and you're screwed too. So security misconfiguration basically mean know what is running on your server and how it is running and how it is configured. Check it. Insecure cryptographic storage. Well, this is hard. This is an area which is basically very hard to enforce, because most of us, at least me personally, have no in-depth technical knowledge of cryptography other than how to use it. I have basic understanding how cryptography algorithms work, of course. We all read security blogs and stuff, of course, but it's hard to test this. But anything anything you can do against it is, again, put up a little bit of a fence and make sure that it's not directly evident what is actually doing. This also is not only for cryptographic storing, this is for hashing too, because MD5, which is mostly the default hashing algorithm, you have this fantastic phenomena called rainbow tables. You have a lot of websites actually where you can input an MD5 hash, and you'd be surprised how many are actually resolved in a matter of milliseconds. So add hashing, add salts, to hashing. Salts can, and I hope everybody's familiar with the concept of salting, but simply add something that is configured on application level to like a password. Basically encrypt privacy or financially related data. A lot of countries actually require this from you. And yeah, maybe to get this out of the way, base 64 encoding is not encryption, it's obfuscating. But at the very least, it is something. And also, don't store data that might become relevant in some particular 1 in a million use case at some time. Applications or application developers tend to have the feeling that they should just log anything, should ask a client for anything. Well, I wouldn't do that. For instance, like payment services gateways exist for a reason, namely that you do not need to store bank information of a user. So don't ask a user for their bank account number if you are using something like PayPal to handle the actual transaction. Why would you do that? Mostly I get answers back like, yeah, but the field is already in the commerce system, so I simply leave it there. Yeah, the problem is, if you have this information, you are responsible for it. And your client is too. But that's a whole different concept, because actually, if you as an application developer or security auditor or any kind of expert role in that matter, do an audit for a client, and you should really tell the client that he's storing information that he is actually required by law to take precautions for. If you don't do that, you could be held accountable if something goes wrong. So be really careful with that. Simply don't store what you need directly to facilitate your logistic process or authentication or something at all. Failure to restrict URL access. Well, I love this one, actually. You know why? This is actually the attack vector that made Google the biggest porn indexer in the world. Because what this is URL access. URLs have IDs, mostly, of pages encrypted in them. If you traverse these page IDs, you'd be amazed how many systems would allow you to actually see pages that are not meant for public display. But like I said before, mostly only the login page has some kind of authentication, and the rest could be just static HTML. Well, this is basically what most search engines did with a lot of sites with some interesting biology. They simply went on and on and on and on and just indexed everything behind page 1. And everything you output to a user should only be done after you have actually validated that this user is authorized. So simply do not assume because the user knows some unique URL, even if you use UUIDs, thank you, instead of integers, that it's impossible to guess a page. It is possible. Not only that, it's very real that a user will not actually perceive a page as being confidential and copy and paste the URL in an email, send it to another user, and here you go. The best part actually are applications which store the session identifier in the URL. This is beautiful because when a user actually copy and paste that URL, puts it in an email, effectively he has created his own session hijacking. Because the user which will open the email, access the URL, will have the session identifier of the other user, and bingo. Insufficient transport layer protection. This is hard because actually the transport layer is every piece of infrastructure between your web server and the client, and you can never be in control of that whole cycle. Even if your country name is Iran, you cannot be in full control of that. Well, what you actually can do is if you communicate through channels which require encryption, test actually that you are actually using this encryption, and not only by looking at PHP self to see if there is this little S behind HTTP. Actually test if Apache has an SSL service session running at that time. I've seen many applications which actually do test if they run HTTPS by simply looking at the URL if it starts with an HTTPS. Yeah, it's cute, but doesn't mean anything. But still, it's hard. If, however, SSL measures are taken, also check actually if they are up to a certain level of standard. And you can use like NIST, or in Europe we have ANISA, which is a agency of the European Union which provides a lot of good information, best practices on what is actually strong enough encryption for certain types of information, and also offer information on how to validate that. And also check if your certificates are up to date. That's also something that goes wrong a lot. Next one, unvalidated redirects and forwards. Web applications point users to other places than the own application, and this is again something that you can share under the topic of injection or cross-site trouble. Actually, what you can do against it is simply implement the countermeasures I've discussed before in URL access restriction and authentication and everything. Just be sure of what you send your user to. And this also goes again back to the redirection issue, because if you have users who have like profile pages on social media, I would really suggest that if you allow a user to have a personal profile page with a LinkedIn profile, well, let him only enter his LinkedIn username, for instance, for accessing his or her page, or simply the final piece of the URL. Construct the www.linkedin.com/ do that yourself, because then you're pretty much okay where a user is going. Because what is pretty easily done, again, is that a user provides a URL which looks valid at first point, but then is redirected to all kinds of other crap. So, test. Is that all? And actually we're just about halfway, I think. So I'm also going to have a look at the time. All right. Also time-wise we're halfway, so bear with me. Is that all? No. There's a lot more to talk about in security, but I think it's a good start that you should at least be aware of these factors and know how to at least identify possible scenarios in which they encounter. But like I said, is it not written that being secure is looking a little less insecure than your direct neighbors? Well, it is written because it stands there. But actually, the same is for airport security. If you work in physical security, like airport security, it's impossible to secure everything. If you have ever tried to take in a flight in the States, you will know what I mean. You have to go through full body scanners. You have to go through just basically about anything which has an X-ray or something. And still, it is possible to bring something in which might be used as harmful. If it were not the black belt of karate of somebody, you know, it's pretty hard to take that out. But actually, the point of security testing and security measure implementation is mostly simply making it very unlikable for a possible attacker to attack your service. Make sure this attacker is completely frustrated after like a couple of hours and says, okay, shit, I have now encountered like measure number 26, I'm done. And also a lot of hacks are being done in some kind of freelance way, actually. You can actually hire Russian or Eastern Europe or Chinese hackers for a pretty decent hour rate, actually, to simply bombard an application with crap. But all these guys work with simple or fixed price or hour rates. So basically, if they've spent their time and the client doesn't pay anymore, the attack stops. So make sure you stand up long enough to survive something like that. DDoS attacking, well, that's basically a different kind of show, because that is simply something you have to sit out and just put down your web server and wait. Not a lot you can do against that. But if you don't use custom applications, or if you do use off-the-shelf applications and you do not want to change them, there's also a lot you can do. And actually, I think there's a lot you should do anyway. Because your web application is only one part in your infrastructure. And infrastructure is always a layered cake of multi-components. And, well, I've repeated this mantra a couple of times now. Hardening. I'm going to talk now a bit about Drupal hardening. And why Drupal? Well, because it's one of the most used CMS platforms. And I feel like I have to explain this a little bit more, because if you look at the general usage web stats of CMSs, you will see it's like WordPress, 80%, Joomla, some percent, Drupal, some percent. Okay, but this is a bit of a false picture, because actually if you look at like the top 1,000 biggest websites in the world, enterprise websites, government websites, you will actually see that Drupal does at least half or more of those. So actually Drupal is one of the systems who is mostly under attack, and also Drupal is usually used for complex websites. I mean, you can build anything complex also in WordPress, but you can basically also drive the 24 hours of Le Mans on a Skelter, which is also not a good idea. So Drupal, actually it provides quite good out-of-the-box security level in the actual framework, because there's a forum API which does a lot of the input validation, which does a lot of the basic tear out shit stuff. There's different levels or profiles of input flexibility. You can whitelist what tags users can use in like WYSIWYG editors, stuff like that. It does input validation and output filtering, very nice. It has an active QA and security team, but alright, I'm not going to do a Drupal advertisement talk here. I'm just going to go into a little bit of how to actually harden the different pieces, the different layers of an infrastructure. So we have just successfully concluded like the theoretical part. Now we're going to go look at the practical part. Server and OS hardening. First, only install or enable something that you actually use. Actually, FTP is just about the worst service you can have access enabled on a server which has any kind of security. Because FTP, by default, well, it was simply made to do very little checking and validation. So disable it. If you need it, you can always log in through SSH and enable it for the period of time that you actually use it, then disable it again, or simply upload your files through an SSH tunnel, which is actually pretty much secure. Use a firewall. I don't think that I need any explanation of that, but actually what you can do with the firewall also is enable administration functionality to a limited range of hosts or guests. Mostly you will be updating your site from, or at least your system, from a very limited set of locations. So why on earth should your administration functionality, like also SSH, or your admin pages for that matter, be world accessible? Well, I really wouldn't know. And of course IP spoofing can be done pretty easily actually, but it's again another measure. And another measure which you can pretty easily take. Refuse pings by default, for instance. I do that instantly because ping can actually also be used to create DDoS nasty stuff. If your website is reachable, then chances are pretty big you don't need ping. Also use hardening of your administration features. Like SSH, you can use something like fail to ban to, if a user account is misused, or if somebody tries to brute force dictionary attack a certain login, it simply enforces a ban for that IP address for a certain amount of time, and it will simply reduce the likelihood of actually having a result. Also, use a non-standard port for SSH. Use like 50,000, I don't know. It's pretty annoying for a hacker to look that far. Use monitoring and validation tools. Like intrusion detection systems if you are really working with sensitive data, but also actually use monitoring tools to look at the logs that your CMS is just generating actually, because most CMSs and also Apache generate pretty decent log files which can be interpreted with automatic tools and which can simply filter out anything that says warning or like disaster, something like that. You should check for that. Or if you want to be lazy, you can use irregularity scanning tools, which can actually email or SMS you if some anomaly occurs. I mean, you can be as lazy as you want to be. These tools can run anyway, and you'll still be informed. Oh dear. You'll still be informed about any kind of misusage. What you actually do need to check if you use those tools, if actually they work periodically, because it would not be the first time that a system is installed at a client and some sysadmin changes the web server or the mail server for that instance, and suddenly the logging mechanism does not email anymore, and you feel completely warm, comfortable and fuzzy in the knowledge that your application is not under attack, while in the meanwhile your monitoring mechanism is trying to send mail like crazy because it's actually just has been hacked. Make sure your software is up to date. Well, duh. Again, use specific users for the different services so that actual authorization in the system can be restricted to anything this user actually needs to do. Use sandboxing like AppArmor. It's pretty easy for most standard services like Apache. It has default profiles in openSUSE anyway. It works pretty well, and it simply is another barrier. If your web application is compromised in any way, or if anybody can upload anything not really nice to your web server, then at least you can restrict the damage. And that's also important, salvaging. What you can use on the web server side. First of all, disable unused HTTP methods. Here we go again, security mix configuration. You should try, just out of curiosity, to configure like the put HTTP method and try to put data into a PHP file on the server. By default, the file gets overridden. Wait, you do that with a standard HTTP command? Okay, you can of course limit that so that the Apache user doesn't actually have to change the files, of course, but still disable or not install anything that you are not actually using. Don't include software names, and absolutely do not include version number in HTTP headers. Why on earth would you actually send that information? It's a misuse of bandwidth. Your client is probably really not interested in the fact that you're running Apache 2.2 with PHP 5.4. I don't know. Again, turn it off. Do not enable directory listings. Really, don't do it. Only return error codes or generic error pages, because you can do this on a web server level as well. If you have a system like Drupal generate a 404 or 403 page, this actually is a normal page of the CMS, which requires the bootstrapping of the whole CMS stack, contacting the database, getting information, rendering a template. That's a waste of time. Install something like Fast 404 for Drupal, which effectively simply detects very early in bootstrapping if some action is actually allowed or not, and returns a cached page. It does not have to go through all the other steps. DDoS attacks usually use random arranges of page IDs to simply bombard a site and evade the blocking of certain pages when being overused. Something like Fast 404 or 403 actually prevents a little bit or mitigates the impact that a DOS attack could have on that. Disable flow symlinks. Also, disable web root directories for users. I don't know. Does anybody even use them? Does anybody of you is aware actually that the default user template of also openSUSE includes a public HTML dir for users? Any user on the system can have their data. This used to be fantastic in academic environments where everybody could simply put their thesis and all kinds of other brilliant information in that folder, and it would become world readable. In current days, it's simply another place that you can store bullshit. Also, and here is the whitelisting mantra again, ensure that only the files, or at least file extensions, are shown directly, like PDF or doc and stuff like that. Those are typically files you want to, or I'm sorry, did I say doc? I meant ODT. Sorry. Those are the kind of files that you would generally want a user to access directly. And make sure everything else gets redirected to the PHP interpreter so that your application can actually do some validation on it. And this also prevents, also a very nice feature of any files is the fact that they are text files, and if your server configuration is wrong and your user or your attacker knows where to look for an ini file, like in sites default config.ini, try to access that file. It will nicely output the database login information, the database server, stuff like that. I love that. When I try to penetrate an application or something like that, I check first if configuration files are world readable. That makes my job so easy. Also, Also, if you run virtual directories, which basically everybody does, do not forget to change all this also for the default directory, or have that not active. Because you would not be, or at least I'm usually surprised, of the amount of web servers which actually have a virtual directory which also is the default directory, and well, you have to enable measures for all of them. PHP hardening. Some people think that this is a contradiction in terms. I actually don't. PHP is pretty secure. Actually, it's not less secure than any other type of language or interpreter. But you can do some stuff in the configuration of PHP which effectively open up the whole world. So you should at least go past a couple of configuration options. And actually these configuration options I did not per se think of myself. The PHP project, and for instance a lot of open source projects, have decent wiki pages put up with security best practices. Check them out, because actually the information there is usually pretty good. I mean, Drupal has like a 16-page security manual of best practices, which is, apart from unreadable, also very informative. But PHP hardening. Maximum execution time. You're on a web server, so don't do stuff forever. If you have to process large amounts of data, use Gearbox or something like that. Offload, Gearman, or some other queuing mechanism which can do it asynchronously. Max input time. Also, why would you want to have your user open up a session or open up a request forever? Don't do it. Basically, look for these options. Most of them I've discussed before, and they'll be in the slides. MySQL hardening, yeah, it is also possible. First of all, do not use MySQL as root, and do not use the MySQL root user for any application under any circumstance ever. Did I say ever? I meant that. Also assign multiple user profiles to applications. I mean, CMSs like Drupal usually run with only one user who can also do database schema updates as well as content updates. Why is that even necessary? I mean, a normal operating website does not have to have create, alter, or drop authorization. It simply doesn't use it. So don't have it enabled, and run a separate database user for a tool like Durage, which is a command line interface to doing a lot of technical stuff with the Drupal implementation. Because simply, if you don't enable the permission, it cannot be misused, or at least it offers another barrier. Restrict MySQL listening to only the web server's IP or the local host. Why would your database need to be world reachable? I have no idea. Oh yeah, do not, I repeat, do not use PHP MyAdmin or severely restrict access to it. Not necessarily because PHP MyAdmin is a bad tool. It's a fantastic tool and it's really functional. But you can effectively bypass any mechanism your web application has in place for authorization, filtering, and anything. You can simply go into the database directly. And PHP MyAdmin out of the box has very little protection for like brute force dictionary attacks and stuff like that. So if you do use PHP MyAdmin, simply restrict IPs or put Modsecurity in place to prevent brute force. I will go into Modsecurity a bit later, but what you can do with that is, for instance, tell Modsecurity to simply protect the PHP MyAdmin login page so that any false login attempt from a certain IP address, after 3 times of false logins, the user is banned for a day or something like that. You can do that with Modsecurity without having to depend on PHP MyAdmin. Look into that, it's really good. Also, of course, prevent direct access to database files and stuff like that. Have backup routines, as I'm sure we all have backups daily. It's really quiet. And do not rely on MySQL replication as a backup strategy, or yuck. Application hardening, Drupal for this matter. It actually, again, a lot of the mechanisms are quite universal for also other applications like WordPress or Joomla. But Drupal has a lot of modules which actually do a lot of out-of-the-box configuration work, like secure permissions, which has a very nice lockdown of the basic permission set. You have secure login. You have the security review module, which gives you a very nice indication whether your file system is being configured correctly with permissions and stuff like that, if your Drupal installation is up to date. You can use flood control to prevent dictionary attacking of the login page, but it's something like fail to ban for SSH. And also, here we go again with the user ID 1. User ID 1 in Drupal is absolutely God. He can do anything. You basically do not want to have user ID 1 enabled on an important system. Simply have an account which is also given all the permissions an administrator wants, but simply do not have it have user ID 1. I know it's security through obscurity, but at least it raises the bar again. Use AppArmor, and actually the good news is, I'm going to check my clock again, we're actually pretty much on schedule here. AppArmor, and if you use it for web server techniques, because actually the good part about AppArmor is you can use it on a per virtual directory base. So actually you can have different sites with different security profiles running thanks to AppArmor, but directly configured to the virtual directory. Also, it is really nice. It has this like profile recording feature, so anytime you have a new application you want to add to your virtual server, you can simply record all the permissions that the profile needs, like access to the temp directory or access to some other thing. And you don't really have to do much manual configuration on it. At least not as much as a Linux requires. And the best part actually is it's integrated with openSUSE and Yoast, so you have very nice control sets. Use Modsecurity. Modsecurity actually is a project of this OWASP thing I was referring to earlier. And basically Modsecurity is a web application firewall for just about any web server available currently. Like Internet Information Services has a Modsecurity plugin, Apache has one, etc. It's the best part is it's a rule-based firewalling mechanism which you can really tailor and configure to mitigate all kinds of attacks on your application. Basic protection includes HTTP protection, blacklist lookups, like if an IP is actually on some kind of spamming blacklist or DDoS blacklist, malware detection up until a certain level. It can check against the Google Safe Browsing API, for instance, if a URL that's in a request or in a get or post variable could be problematic. It offers common web attacks protection, which means it looks for like SQL commands in get and post requests, which is I think pretty useful because normally you would not allow a user to use like SQL language in any kind of statement anyway, except of course for PHP MyAdmin perhaps. It can detect most bots and crawlers and stuff like that by simply looking at the client identifier. You can integrate it with antivirus scanning, which is nice, so you can like automatically scan uploaded files or at least have protection against that. A lot more. Really look into it. It's a fantastic module. But to be honest, it does require a lot of work to get running reliably. If you have a Drupal instance, for instance, with a WYSIWYG editor, what you should basically do to implement Modsecurity is enable all rules and put it in detection-only modus. Just a bit like recording a profile with AppArmor, actually. Then you should run a complete set of functional tests and actions on your web applications. You should enter content, you should upload files, you should use the search function, you should add users, change permissions, whatnot. Then you should look at the log file of Modsecurity, which rules are triggered, because most likely these are false positives. Then you disable these rules, pretty simple through configuration, and then you put Modsecurity out of detection-only modus into real scanning. You can also, on a per IP basis, for instance, or IP range basis, disable Modsecurity for certain IP ranges. This could be useful if you have like a very sending-only type of website, so you can simply have a very strong security profile for anything except your administration users. But actually Modsecurity is, I encounter it more often each year actually. It's becoming pretty much the de facto standard. Well, I'm actually quite done for now. So, are there any questions? I see some hands. All right, I'm going to let you...
I have a question to authentication with the API. What would you do if you give employee or anybody else a user account and he used that for attack?
First of all, I'd sue his ass, and second of all, yeah, there is always the human factor. What you actually should have also in place next to technical measures is procedural measures, like having passwords updated regularly, having a good identity management, lifecycle management solution in place to disable accounts for users which do not work for your organization anymore. But yeah, you're basically asking the ultimate nightmare question of every corporation. What if an insider decides to screw up my business? Well, basically, you're screwed. But then, back to the backup part, which of course everybody does, you can always restore something and go back to a previous situation. I know it's a very unsatisfactory answer, but I'm afraid it's the only one. Anybody else? You in the pink shirt, and I see some hands there too. Bright light.
Which one do you consider the most secure CMS? You mentioned, I don't know,
personally,
both in terms of default settings and how easy you can get it to be more secure.
Let's narrow down that question a little bit.
Drupal, WordPress, Joomla.
Like PHP-based CMSs, you can install on a shared hosting environment. Yeah, personally, I'd go for Drupal anyway, because it simply is out of the box. It's pretty secure. It has very good community audit process of module testing. Drupal has a lot of contributed modules which are actually looked at by a team of not only code quality but also security reviewers. So basically the whole package is pretty good. But to be honest, it depends on your situation, and it also depends on the level of interaction you want a user to have with the site. Because if you have a very basic like information only type of website, like a news blog or something, yeah, then WordPress is also pretty alright. But personally, my company has most expertise with Drupal, and I personally like the fact that not only code quality is checked, security quality is also high, and they have an active and responsive security team which actually has a role in the release management. So I'd go for Drupal, but I am not the most neutral person to ask. So,
thanks.
All right.
Also, you mentioned openBase during AppArmor, and are there any performance issues, concerns we should have about that? HT-Access has a performance penalty.
Yeah.
Does AppArmor and openBase there have any similar concerns?
Actually, openBase there does not have a performance penalty at all because it's simply a constant in the PHP interpreter. No, it's really nothing. AppArmor, yeah, it adds a little bit of overhead, but really minimal, because actually it is simply a pass-through mechanism, filtering type of thing, and because it works with whitelisting, it's pretty narrow in what it has to check, so it's pretty lean. Modsecurity also is pretty lean. Yeah, it does add a bit of overhead, but these are like in the 0 to 1% performance penalty ranges. And actually Modsecurity is invaluable when it comes to like brute force attacks and stuff like that. You'd be amazed how many websites are being scanned for potential flaws on a daily basis. If you are on a regular .com domain or .nl or something like that, you can expect just about a monthly or weekly passing by of some interested party from, for instance, the Far East or something. And actually Modsecurity, what it then does is simply block these brute force range attacks. So actually this has a positive impact on your performance because it simply does not have to handle that kind of bullshit. But yeah, security measures are, whether they're technical or procedural, they always raise a little bit the amount of effort the web server has to perform, but also a user has to log in, which is also a little bit of a procedural performance penalty. But in my experience, actually using like AppArmor and Modsecurity and openBase there and stuff like that, it's not noticeable at all.
Okay, thanks.
All right.
Another question. Does it make sense to change more popular applications like Apache and MySQL for less popular ones, like Nginx or PostgreSQL?
No. No, I don't think so. You might have a performance reason, however, especially Nginx, of course, it's been written with only one goal, it's being blazingly fast. So you might have different reasons, but from a security point of view, no, it's all software which is pretty popular and which has a pretty decent QA process behind it. Basically, what you should look into is restricting the amount of impact an actual attack, successful attack, can have on your system by sandboxing stuff like that. If you do that, basically you're good.
Thanks.
All right, I saw a hand behind there. It's still waving. Hello there.
I have. Can you? Am I?
Hello. Can you speak up a bit?
Some applications, there is a tendency in Web 2.0 that the web applications tend to be theme clients for service-oriented applications. Yeah. So we have clients that are using our application through a web UI, like a web page, or they build smart clients who use directly our web services. How is it possible to secure our back office web service application in order to track those actions? Because I think that in a slide you said that we have to be careful with session cookies and session variables, and to track the path that led to this session variable creation. When we have those kind of applications, and we have both classic web pages, but also web service clients, how can we be so sure about this safety?
Well, pretty much the same way as you would go at web pages. Actually, from an architecture point of view, if you look at an application, the only difference between using an actual web browser or using a API client is the fact that the application doesn't need to render a full-fledged HTML page. But apart from that, the bootstrapping mechanism is just about identical. The authentication layer is also just about identical. Actually, the only thing that it doesn't need to do is like produce HTML. It has to output like XML or JSON or something like that. So if you know that, I mean, it's like all going through this one way down, only has different heads, then you should focus on how the actual interaction part can identify indeed the session or something like that. Basically, what you can do is also implement, since it's the HTTP protocol, it's pretty trivial to embed session IDs in your here we go again, in your requests, and it's not like best practice to have different type of session identifiers for your different front ends. As long as the actual session and the actual filtering and validation passes through your application architecture, you can pretty much use something else. What you can also, and that's actually a good thing about smart clients or like API consumers, is you can also embed your own type of challenge response mechanisms, stuff like that. And that's something you can pretty much not do with a regular web browser because, yeah, well, that's pretty much limited to JavaScript and cookies. And most of the times, session data or IDs will be stored in cookies. And these session IDs, you basically do not want to be reachable from JavaScript because then they can be hijacked by some other browser script. In intelligent clients or API consumers, you can have all types of different authentication mechanisms. You can also use SSL certificates, for instance. But actually, I think that whether you use a web browser session or a custom-made application, since actually the whole workflow of validating input, filtering output, authentication checking should be done by standard components in the application, I think that basically is not that much of an issue. Did I answer your question satisfactorily with that?
Yes, thank you very much.
All right, cool, you're welcome. Anybody else feels lucky? Then I would very much like, or did you have a question or did you just yawn? All right, cool. I would like to thank you for being here and listening to me here. It's been a pleasure to be here at the openSUSE conference with all you great people. And I hope to see you again in future sessions. Thank you.